Yes, that's right. You saw the title. Today we are watching 81 math symbols explained by Digital Genius. Make sure to subscribe to him. Okay, let's start.
Starting with the most basic symbols, the
Addition.
plus sign is universally recognized as the symbol for addition.
Yeah.
Minus sign, which is essentially the opposite of the plus sign,
Okay.
represents subtraction, but it can also
Yeah,
denote negative
subtraction.
numbers.
Yeah.
Multiplication
Okay.
sign is used to denote the operation of multiplying two numbers together and can
Uh,
also be represented as a dot. The division
Okay.
sign signifies division, the opposite of multiplication. It
Uh,
can sometimes be written as a slash. Plus
that's
minus
subtraction.
denotes either plus or minus.
The fuck is that? A
It can
Christian
also used
sign?
to denote a range of values.
Looks like a
Its
cross.
counterpart, minus plus sign,
What the
is
hell?
used in conjunction with the plus minus
What the
sign.
fuck is
It
that?
denotes the opposite sign of plus minus. For example, this expression
What is that?
it's either a plus b minus c or a minus b plus c.
Why?
Both signs can't be the same. The
Oh.
root symbol
Why?
denotes the square root of a number with an integer greater than 2.
That's a square root. It looks like a fucking check mark.
As left superscript, it can denote the nth root of a number. The equal
What?
sign, represented by two lines which are equal
Yeah.
in length, is used to denote the equality between two expressions.
Yeah.
The opposite of the equal sign is the not equal sign, which indicates that two expressions are
Oh.
not equal. Approximately equal sign is used when two
What the
values
fuck
are
is that? A
not exactly
wave?
equal, but are close enough. Instead of
Close enough.
approximately equal sign, we can also use tilde. But
Close
tilde
up. What?
also denotes similarity or
What the?
proportionality. This symbol that looks like an unfinished infinity also
Yeah.
represents proportionality. The
Oh.
triple bar or the equivalent sign
What?
can be used to denote an identity.
Isn't that
But its more
geometry?
common use is to denote congruence in modular arithmetic. The less than
What?
symbol is used to
Oh yeah, and
indicate
then there's
that
some
one
more
quantity
sign
is
symbol,
smaller
and
than
then
another. Its
the equal,
opposite,
which
the
shows
greater
what it's
than
saw.
sign, is used to indicate
Yeah.
that one quantity is larger than
See.
another. If we add a line to the less than symbol, we get less than or equal sign. As
What?
the name suggests, it indicates that one value is smaller or equal to another. The
Okay.
same is true for greater or equal to sign. Using
Okay.
two less than signs, we can denote much less than sign.
What?
The same is
Oh.
true for much greater than sign. Empty set symbol denotes a set
That's a
that
0.
contains no elements. Number sign
No
also
lemons.
known as octotrope or
That's a
hashtag.
hashtag. Yeah, that's a hashtag.
Cardinality of a set, which is essentially the number of elements in the set.
Why is
In
there a
symbol
P?
denotes membership in a
That's
set.
in
Its
euro.
opposite, not in symbol, denotes
That's
that
in the euro.
one element is not a member of the set.
Why
The
is the
set
currency?
inclusion sign represents that one set
That's
is
a
a
big ass
subset
C.
of another set. If we add a line, we get a set.
Hold on. That shit looks like a fucking horseshoe to me, bro. You ever seen a horseshoe?
That also denotes set inclusion.
What the fuck is that?
Used for emphasizing that the sets can be equal. If we
Oh.
cross that line, we get a symbol that denotes a proper subset, meaning
Oh.
that the sets are not equal. Union
Okay.
represents an operation of combining two
That's
sets,
a U.
which
The
results in another set containing all unique elements from both sets. Intersection
What?
denotes another operation of combining two sets.
What the hell is
result of
intersection?
is a set which contains
That's another
elements that
horseshoe.
are common in both sets. Set difference is denoted by a backslash.
That's
The
a
result of
fraction.
this operation is a set which contains all elements of the first set that are not in the second set. Symmetry
What?
difference can be denoted by a
That's a
triangle or a
triangle.
circled minus. The result of this
What?
operation is the set that contains all elements that belong to exactly one of the two sets.
That's half a circle.
Symbol is used in logic
What is
to
that?
indicate the opposite of a statement.
It looks like
or
the
operator
Waluigi sign.
returns
Okay,
true
that's a
with
V.
at least one of the operands is true. And operator
What?
returns true only if both
Oh.
operands are true.
What?
Exclusive OR operator returns true if exactly one of the operands is true. T denotes
What?
logical constant for true value or
Oh.
a statement that is always true. Updek represents logical constant for
What the
false
hell is
value
that?
or a
It's a-
statement that is always false. Universal quantifier asserts that a statement is true for all elements in a given domain.
That's
The
an upside down
existential
A.
quantifier
That's
asserts
another
that there
E, bro.
exists
What
at
the
least
hell is
one
these signs?
element in a given domain for which a particular statement holds true. Uniqueness quantifier is used to assert that there's exactly one element in a
Isn't that
given
a-
domain for which a particular statement holds true.
I know what that.
Conditional operator denotes an implication between
That's an
two
arrow.
statements. If the first statement is true, then the second is also true. A logical equivalence operator indicates that two statements have the same logical value.
Oh.
The capital letters written in blackboard bold typeface usually denote
A,
the
B,
basic
C,
number systems.
D.
N denotes the set of natural numbers. Z denotes the set of integers. Q denotes the
What?
set of rational numbers.
Wait,
R
what?
denotes the set of real numbers. C denotes the set of complex numbers.
What the
H denotes the set of quaternions.
What?
O denotes the set of octonions. U denotes the universal set, which is a set that contains all possible values. In Lagrange's notation, apostrophe is used to denote the derivative of a function. By adding the second apostrophe, we can denote the second derivative, the third for the third derivative, and so on. In Newton's notation, the derivative is denoted as a dot. It is usually used to denote a derivative of a variable with respect to time. Adding the second dot, we can represent the second derivative. The Leibniz notation for derivative represents the derivative of a function or a variable at the top with respect to the variable at the bottom.
What are you saying?
If we round the d, we get a notation that represents the partial derivative. It is used for a function of several variables. Integral denotes an antiderivative, which is basically the opposite of the derivative. With subscript and superscript, it denotes a definite integral, which represents the area under a curve or the accumulation of a quantity over an interval.
Yeah, sure, bro.
Is sometimes used to define a function without having to name it. Function composition is an operation that combines two functions. Logarithm is an inverse operation of exponentiation.
It's just log. What the
denotes the base of the logarithm. Log without a subscript represents the logarithm with base 10. The natural logarithm, denoted as ln, represents a logarithm with base e. Limit is used to denote the behavior of a function or an expression.
These are just letters at this point.
Value. The fancy r denotes the real part of a complex number.
What the hell is...
The fancy I denotes the imaginary part of a complex number. Using a bar above a complex number, we can denote the complex conjugate of that number, which just changes the sign of the imaginary part of the number. Greek letter sigma is used to denote summation.
Wait. Guys, we've done our searching. We found the true sigma. Oh my god, the true sigma. Oh my...
A series of terms. Capital Pi works the same as sigma, but it denotes a product.
Oh my, there's a capital pi?
It denotes a concept of unlimitedness. It signifies a value that is greater than any finite quantity. Aleph is used to represent the cardinality of
okay, now we're in the infinities at this point.
Represents the cardinality of the set of natural numbers. Factor C
infinity is still going.
Infinity. It represents the cardinality of the set of real numbers. Factorial is an operation.
Yeah, the factorial, I know this.
By all positive integers smaller than that number. Binomial coefficient looks like a fraction without a line, but it represents the number of ways to choose k elements from a set of n elements. Absolute value of a number represents the distance of that number from 0 on the number line. The floor function returns the greatest integer less than or equal to the value. On the other hand, the ceiling function returns the smallest integer larger than or equal to the value. Nearest integer function, as its name suggests, returns the nearest integer to a given value. Single line represents divisibility. This line crossed represents non-divisibility. Two lines denote parallelism.
Add a cross. I knew it.
Represents non-parallelism. Upside down T represents perpendicularity. Sometimes it can also mean that two numbers are co-prime. Bar over 2 points represent a line segment between those points.
Great, geometry.
Over 2 points represents a ray starting at the first point and ending at the second point. Arrow pointing in both directions represents an infinite line passing through both points.
Anyways, guys, this is the end of this video. Make sure to check out Digital Genius that made the entire video, make this video happen. Know if you want more videos like this, and stay tuned, I guess.